Welcome back to Applied Algebra. Today we're going to work on solving equations. So first we're going to make sure we know the definitions of the terms. So our equations are algebraic statements that include an equal sign. They can be very complex or very simple. An identity is when we have multiple answers that we can use. A conditional equation is one that is true for only some of the values and not true for others. And the solution, or the root, sometimes you'll even hear it called a zero, is the answer that we're looking for. Equivalent equations are when we have two equations that have exactly the same roots. Now, some of the rules that we're going to use to solve these, and you can always refer back to them if you get stuck. First thing you should always do is add or subtract the same algebraic expressions, and you want to do that to both sides. Then you want to go ahead and do multiplication or division. Then you will combine like terms on the other sides of the equation, or the equal sign. Then you'll go ahead and replace one side or both sides with an identity and interchange the two sides of the equation. So just remember the saying, what you do to one side, you do to the other. That way we keep it equal. Because the equal sign is like balancing the equations. So this very first one, we have to find what plus 8 equals 26. And we're starting simple, so this you probably could figure out without doing any algebra. But we're going to go ahead and do the algebra just to practice. Since this is adding 8 on the left-hand side with the x, and I want to isolate the x, I'm going to do the opposite of addition, which is subtraction. So I'm going to subtract 8. But if I do that to the left-hand side, I have to do it to the right-hand side. And sometimes what helps individuals, if you think of the equal sign as a line, and that way you know what you do on the left, you have to do on the right. The 8 minus 8 crosses out, leaving us with just x equals 26 minus 8 is 18. So that is our solution. Now, if you're never sure if you get the right answer, all you have to do is check it, take your answer and plug it back in where the x was. So 18 plus 8, does that equal 26? 18 plus 8 is 26, so we have checked that I did get the right answer. So we're going to go ahead and do number 2. Now when two things sit next to each other, that is a multiplication. So this is saying 4 times x equals negative 26. Again, if we think of this as a line, the multiplication, I have to do the opposite of that, and the opposite of multiplying is dividing. So I'm going to divide both sides by 4. What will end up happening is this 4's will cancel, leaving me with just x. Negative 26 divided by 4, and I intentionally made some of these not come out as whole numbers because some people feel like if they don't get a whole number, they've done it wrong. That is not true. Just means it's not a whole number. It's not like when we do anything with money that we always end up with just whole dollars. Many times we end up with partial dollars like quarters or 50 cents. So I have an x equals negative 6.5. So again, I can check it. Is 4 times negative 6.5 equal to negative 26? 4 times 6 is 24. Half of 4 is 2. The 24 and the 2 makes negative 26. Now I'm not going to check every problem, I just want to make sure that this is how you know how you can check your answer. Now every time will I give you an odd number so you can check in the back of the book, so here's how you do it. Especially like on an exam, you can't check your answers. So you need to have a tool. Now this one has like terms on one side, so actually we're going to go ahead and combine like terms before we do any movement. So I have 6x minus 4x, that's 2x. 2x minus x is actually just an x. 30 minus 23 gives me 7. So by combining like terms, I ended up with a very simple expression that I actually have nothing else to do. X equals 7. On number 4, there's nothing to combine on the same side, so I am going to go ahead and start moving. Remember in the rules above, and refer back to them if you need to, it said to do any adding or subtracting first. So since I'm adding 38, I'm actually going to subtract 38, but I take that back. I'm not going to do that. Now the reason I decided not to do that was because I have a 4x and a 7x, and moving the 38 is going to do me no good. I actually need to move like terms together. So instead of moving the 38, we're actually going to move the 4x. By doing that, I'm going to end up with my x's on the same side. So I'm going to combine like terms to the same side. I only end up with 38 on the left. 7 minus 4 is 3. So 38 equals 3x. Now I am multiplying the 3 and the x, so I'm going to undo that by dividing. So I need to figure out what 38 divided by 3 is. So in decimal form, I get that 12.6 repeating equals x. And again, I can check that if I want. I would go 4 times my answer plus 38. Does that equal 7 times my answer? Okay, moving on to number 5. This time I have y's on both sides and constants on both sides. So I'm going to combine both my constants to one side and my variables to the other side. So let's go ahead and minus the 7. It truly doesn't matter who you start with. I could have moved the y's first if I wanted to. So I have 8y, 327 minus 7 is 320 minus 4y. So I've combined the constants. Now I'm going to combine the variables. So I'm going to add 4y because that's the opposite of subtracting. So I have to come over here and add 4y. So 8y plus 4y is 12y. And the 320 is all by its lonesome. So I'm going to bring this on up since I'm out of room. So 12 times y is occurring right here. So to move the 12, I have to divide it because that's the opposite of multiplication. So I'm going to do 320 divided by 12. And I get 26.6 repeating. So see, these aren't beautiful numbers, but that's okay. That doesn't mean I'm doing any of the process wrong. Okay, looking at number 6. So they're getting larger, which just means they have more steps. Now I have the distributive property going on, and I would always want to get rid of parentheses earlier than later. So we're going to go ahead and do the distributive property all the way through here. 4 times the 5z, 4 times the negative 9. 3 times the 4z, 3 times the 6, 5 times the z, and 5 times the 8. So I have 20z minus 4 times 9 is 36, plus 3 times 4 is 12, 3 times 6 is 18, 5 times, there's an invisible 1 there, so that's 5z, 5 times 8 is 40. So we're going to actually go ahead and combine like terms before we do any movement. I have a 20z and a 12z, so that's 32z. And I have a negative 36 and a positive 18, so I have a negative 18. And there's no like terms on this side, so they'll just hang out. Okay, now that I have like terms combined on one side, I'm going to go ahead and put like terms together on opposite sides. I'm going to go ahead and start with the constant. Again, it doesn't matter. So since I'm going to move this 18, it's subtracting, I'm going to add 18. So I get 32z. It's the only thing left over here. Still have the 5z, and now I have 58. Again, I'm going to bring it up just to save room. So since I have a constant on the right, I need the z's to go to the left, so I'm going to minus 5z. Now you might be asking yourself, how do I know that I'm subtracting? Because there's no addition sign. But if there's no sign in front of your variable or in front of your term, I know that's a plus. It's a positive, so the opposite of a positive is a negative. So now I'm going to come over here and minus the 5z. 32 minus 5 is 27z. That's equal to 58. So now what I'm going to do is these, I got ahead of myself. Let me back up just a little bit here. Okay, the 27 and the z are multiplying. And so I'm going to divide by 27. So I get z equals 58 divided by 27. It's 2.148. Okay, so now we're going to get into some that actually might have some fractions, and that's okay. We just have to learn how to deal with fractions. They do happen sometimes in life. So I have a 3 in the denominator of this one and a 4 in the denominator of this one, and so really what I would like to do is get rid of the fractions, which is the denominator. To do that, I'm going to think, what does 3 and 4 go into? Well, the smallest number they both go into is 12. So I'm going to distribute a 12, and I'm going to multiply it by each term. So 12 times my invisible 1 is 12n. I still have the 3. 12 times 6 is 72. 12 times 3 is 36. N's carried along. Then I still have the 4. Now, you're like, well, they haven't gone away yet, but they will in just a second. Take your top and divide it by your bottom. So 12 divided by 3 is 4. So I have 4n plus 72. 36 divided by 4 is 9. So see, I don't have any denominators anymore, and it's much easier to deal with. So I'm going to go ahead. I have n's on both sides, so I'm going to minus the 4n to move my constants to the right. So I end up with 72 on the left. 9n minus 4n is 5n. The 5 and the n are multiplying, so the opposite of multiplication is division. So n equals 72 divided by 5 is 14.4. Now also what sometimes happens when we're dealing with fractions is we use what's called a ratio. And a ratio is just a combination of where you're comparing two numbers. So in this one I have a ratio of 5 meters to 4 meters. Ratios can be left as is. They also can be written as a fraction, or they can be written with a colon. Now 5 and 4 are in simplest form, so there's nothing I can do there. So it can stay as A, it can move to this section, second part, or it can move to this part. So there's nothing really to do on this, just to show that. Now on B there's a little bit more work, because notice this is in feet and this is in yards. We would prefer that they're in the same thing. So you can always choose to either move feet to yards or move yards to feet. I'm going to go ahead and move feet to yards. I know there are 3 feet in 1 yard, so 6 feet would equal 2 yards. So I'm going to change the 6 feet out and I'm going to make it become 2 yards. So I'm really doing 2 yards to 5 yards. So this would be one way to write my ratio, 2 yards to 5 yards. I could also write it as 2 to 5 in a fraction form, or 2:5. Notice once I have the same units, I no longer need the yards anymore. So 3 meters to 46 centimeters. Let's see, 1 meter, let's make that look better. 1 meter is 100 centimeters. Now if you don't know these types of things, there is a conversion table in your book. I will also put one up online so you can use that one as well. So I'm going to, if 1 meters is 100 centimeters, then 3 meters must be 300 centimeters. So we're going to replace the 3 meters with 300 centimeters. So it's 300 centimeters to 46 centimeters. Now in this one, the 300 and the 46 actually can be reduced to simpler terms. They're both divisible by 2. So we're actually going to reduce that to 150 centimeters to 23 centimeters. So math-wise, what I did was I divided both of these by 2. So the 150 to 23 is one way I can write the ratio. I can also write it as 150 over 23 in a fraction, or 150 colon 23. So that's what a ratio would do, and we're going to use those here in a little bit. A driving gear has 38 teeth, and the driving gear has 38 teeth, and the driving gear has 10 teeth. What is the gear ratio of the driven gear to the driving gear? That's a mouthful, this whole driving. So they went driven, and then they went driving second. So 38 to 10. But both 38 and 10 can be reduced. They're both divisible by 2, so we're going to do that. And when we do that, we end up getting 38 divided by 2 is 19. So it's 19 teeth to 5 teeth, or 19 over 5, or 19 colon 5. Okay, so we've talked about a ratio already. That also can be thought of as a rate. It's a way to compare two types of different units. And then a proportion is when we put two ratios equal to each other. So first, let's just deal with a rate. An automobile travels 354 kilometers in 4 hours. What would be its rate of speed? This would be if you are anywhere that we deal with the metric system, which is most every other country besides the United States. We would be thinking of this as miles per hour. So I'm going to do 354, and I'm going to go ahead and do it in a fraction form because I want to see what I would get. 354 divided by 4 is not a whole number, but that's okay. I'm going to go ahead and go 354 over 4, and what I get is 85.5 kilometers per hour. So by going all the way down to 85.5, I'm seeing how far I can go in 1 hour. That is its rate of speed. Okay, now we're going to start getting into the whole idea of a proportion. So 6 to 8 equals x to 54. So I have a ratio equaling a ratio. I'm actually going to turn it into fraction form. 6 over 8 equals x over 54. Remember, that was one of the ways we can do it if it's a colon. And the way we solve a proportion is what we call a cross product. Now this is different than when you're multiplying fractions, okay? This is only when there's an equal sign in the middle. So what we do with a cross product is we multiply the 6 and the 54, and we multiply the 8 and the x. And one way you can remember to multiply is that when you look at this, it looks like a multiplication symbol. So that helps you remember to multiply. So it's 6 times 54 equals 8 times x. 6 times 54 is 324. Now I can think about how am I going to solve this equation. I am multiplying the 8 and the x. To make this move, I'm going to divide. That will get my x by itself. I'm going to come over here and divide. 324 divided by 8. So my x ends up being 40.5. If 85.6 liters of fuel are used to drive 870 kilometers, how many liters would we need to drive 4,865 kilometers? So we can solve these types of problems using a proportion. So what I'm going to do is put the fuel on top, 85.6, and the kilometers in the denominator. So I'm doing fuel over kilometers. Now, what I do have to make sure I do is stay the same. So when I come to do the ratio on this side, I have to make sure fuel's on top, kilometers are on bottom. So I'm actually looking for the fuel, so that's my variable. And I know the kilometers, that's 4,865. So I have a ratio because I have a fraction equaling a fraction. So I'm going to cross multiply. So we're multiplying the diagonals. So I get 85.6 times 4,865 equals 870 times x. So 85.6 times 4865 is a nice big number, 416,484.5. Now I'm multiplying, so since I want to get x by itself and this is multiplying, I'm going to divide. If I divide on the right, I have to divide on the left. So I will need approximately, and I'm going to put the approximate sign because I'm actually going to round this number. If you're looking at your calculator as I'm looking at mine, there's no pattern, it doesn't repeat, and it definitely does not stop. So that's why I'm going to round. And since this went to the nearest tenth, I'm going to go ahead and go to the nearest tenth. So 478.7 liters is approximately what I will need. Now we're going to do more fractions, and we did some earlier, and the first thing we did earlier was we did eliminate the fractions, and I try and do that every time I'm doing the fraction ones, no matter how complicated they look. Then we're going to go ahead and remove the grouping symbols, then we're going to go ahead and combine the like terms, get all the terms on the same side, and then check our answer, especially if we're not sure if we did it right. Okay, so our denominator is 5, 4, and 3. So we're trying to think of the smallest number that both 5, 4, and 3 go into. So let's just do the first two to start, 5 and 4. 5 and 4, the smallest number would be 20, but 3 doesn't go into 20. So the next number that 5 and 4 will go into is 40, but 3 won't go into 40. So the next one is 60, and 3 does go into 60. So we're actually going to multiply all of these by 60. Now, here's how I'm going to write it so it doesn't get confusing, because I've got on the tops I have binomials, I have a distributive property, so we've got lots going on. So what I'm going to do is I'm going to do 60 times 4p plus 8 over 5. So I'm keeping this separate, and I'll show you why here in a second. So I'm going to do 60, 3, p minus 6, still over the 4, 60, p minus 4, all over the 3, and then 60 times 7. Now, if you do a lot of this, you may not need these brackets to help keep things separated, but until you get good at it, keep them going. Okay, so what I'm going to do now is get rid of these fractions. So I'm going to go 60 divided by 5. 60 divided by 5 is 12. So this is 12 times 4p plus 8. So I've gotten rid of the fraction, I just have the distributive property now. Minus 60 divided by 4 is 15 times 3 times p minus 6. 60 divided by 3 is 20 times p minus 4, and 60 times 7 is 420. So now I'm going to go ahead and use the distributive property. Now, I'm not going to go ahead and do all of the distributive property in this one because I actually have multiple distributive properties here. So I'm actually going to just distribute to the first one here. So what I'm going to end up getting, 12 times 4 is 48p plus 12 times 8 is 96 minus, I'm going to go ahead and do 15 times 3 and get 45, but I'm not doing it with the p minus 6 quite yet. I don't want to make a mistake. 20 times p is 20p. 20 times 4 is minus 8 plus the 420. Now before I do anything else, I want to go ahead and do this distributive property, the 45 times p and 45 times 6. So notice I'm doing it in a couple steps because I don't want to lose anything. The rest of this is just going to tag along, wait till I'm ready to work with it. 45 times p is 45p. Now, I did do negative 45 times a positive one to get a negative 45. Negative 45 times negative 6 is a positive. 45 times 6 is 270. and everything on the right just tags along. Okay, so now we're going to go ahead and put together like terms. I have a 48p minus 45p, so I'm only left with 3p. I have 96 plus 270, so 9 and 27 is 36, so it's 366. Over here, the only like terms I have are the constants, so I have 20p plus negative 8 plus 420 would be 412. So now what I'm looking at is I'm going to still go. I have to put together my like terms on opposite sides now. So I'm going to minus the 3p. So I have 366, and I'm running out of room, so I'm going to slide right here. 366 equals 20p minus 3p is 17p plus 412. I have to divide, nope. So remember, I can't do the division yet because I have to do any adding or subtracting, so we're actually going to minus the 412. 366 minus 412 is a negative number. In fact, it's negative 46. Now my last step I'm going to do is I'm actually going to do my division, so I'm going to divide by the 17. So negative 46 divided by 17 is definitely not going to be a nice number, that's fine. P is approximately negative 2.7. Now, notice I didn't put my line as I was going down. So I dropped the idea of keeping things separate from side to side. If you didn't like that, as you're going, just go ahead and put it back in. So that one there on 13 looks like it was our last one. If you need any help on any of these, please let me know and I'll send you some other guidance. And if it's a specific one, you can tell me that too, and I'll address that specific question. With that, have a good day, and I will see you on the next video.